Hello and welcome my dear students. Today we will discuss about median of triangles. We will start with practice set 4.1. Now in this figure you can see the perpendicular segment, that is the altitude. The perpendicular drawn from the vertex to the opposite side is called as altitude. So they are asking in triangle LMN, dash is the altitude, dash is altitude, and dash is median. Which is altitude and which is median? Very easy to identify. Wherever you see perpendicular sign, that is the altitude. So the altitude is segment LX. Segment LX is the altitude and segment LY. What is this median? The median is the segment drawn from the vertex to the midpoint of the opposite side. That means for side MN, this point Y is the midpoint. Is the midpoint means MY is same as YN. Point Y is the midpoint of segment MN. Means if segment MN is 6, then MY will be 3 and YN will be 3. The point that divides a segment into equal parts is called as the midpoint. So the segment joining the vertex and midpoint of the opposite side. For vertex L, the opposite side is MN. And the segment joining the midpoint and the vertex, okay, is called as the median. So in this figure, you can see vertex is L and the midpoint of the opposite side is Y. So the name of the median is segment LY. Okay. In detail, we'll be discussing about medians now. Okay. So let's start with in the previous class, we had done the second sum and the fourth sum. That is related to altitude we have drawn. Now today we will be dealing with median. So let's take the third sum now. In the third question, they are asking us to draw triangle STV, and that is an obtuse angled triangle. Obtuse angled triangle. Draw the median and show the centroid. What is centroid? I'll explain to you as we draw the medians. Okay. So first let us draw an obtuse angled triangle. I have this obtuse angled triangle, as you can see. Join. Yes. So any one obtuse angled triangle. They have asked us to give the name, so only this name we have to give. STV. Should be anti-clockwise or clockwise. Okay. So STV means STV. I have done anti-clockwise. If you want, you can write STV clockwise. Okay. Anyhow, don't give the name. Okay. So we have the triangle STV, obtuse angle triangle, and we will show the median. For that, there are two methods. One is simple method and the other is 100% accuracy method. So I will teach you first with the geometrical instrument, and next sum we will do by simple method. Okay. So for that you need your compass. We have our compass and we will draw midpoint. We will construct the midpoint. We will get the midpoint by this geometrical construction. Let us start with one side at a time. First I will draw the midpoint I will get the midpoint for segment TV. So midpoint means the point which divides segment into two equal parts. So that we will get if you draw perpendicular bisector. That is a line which is perpendicular as well as divides the side into two equal parts. Bi means two. Bisector means dividing into two equal parts. Okay. So how will we draw the perpendicular bisector? I will show you the easy method. You can draw this way. For side TV, let us keep the compass at one end point V. Take more than half. This is more than half. One arc here. One arc here. Similarly, without disturbing, keep it on T. cut the arc, cut the arc. So here we got 2 points. Without joining also you can get the, without drawing perpendicular actually. See to it that the scale passes through both the midpoint perfectly. Okay, here, this way. So now, as here I am not drawing the perpendicular bisector. I just want the midpoint, no? Okay, so I want the figure to look neat. So this will be your perpendicular bisector. Where is this perpendicular bisector passing through segment TV? That is this point. So I will mark this point. I will not draw the line. I will mark the midpoint. This is my intention, to get the midpoint. So this midpoint is marked. Okay. Now, how will you draw the median? Median is from the opposite vertex. So TV's opposite vertex is S. S to this midpoint I will join. Very carefully. Okay. S to the midpoint. Understood? Now similarly, we will draw perpendicular bisector for ST and for side SV. First we will draw for ST. Same way, keep the compass on T, take more than half, one arc here. If you want, you can rub this arc, previous arc you can rub, keep it on S. See, this was S, and here. So, okay. So, this was one point. I'll highlight. And this was the next point. Now, let's join. I'm not actually joining it. I just want the midpoint. Okay. This way, you will draw the perpendicular bisector. Now, this perpendicular bisector is touching segment ST at this point. So, I got my midpoint without drawing the perpendicular bisector. I want the figure to be little neat. So here, this is the midpoint of side ST. So ST's opposite vertex is V. So let us join the midpoint and the opposite vertex, that is median. Here I'll be little more careful. Okay. Not like this, no, it went little bit out. So first side over, second side over. Now third side, that is SV. Keep the compass on V. You want, you can rub off these arcs. Keep the compass on V. More than half. This much is enough. More than half. One arc here. One arc here. Same way, S is this point. Point S here and here. So I got 2 arcs, point of intersection. Now without drawing the perpendicular, I will just find out the midpoint. Okay. This way I am doing so that the figure looks neat. So here it is passing, no? Here. So where is it cutting segment SV? This point. So this is the midpoint. Okay. Now join T to that point. SV's opposite vertex is T. Join T to that point. As you can see, again, all the medians are meeting at a common point. The point of concurrence of the median is called as centroid, and we will denote it by letter G. The point of concurrence of median is called centroid, and the centroid is denoted by letter G. The point of concurrence of altitude is called orthocenter O. Point of concurrence of median is called as centroid. Will you remember? Okay, you can rub off these arcs. We don't need these arcs. We only need the medians. We got the medians. We can name it. Suppose, let us start with point S. SM. Okay. Second vertex TO. VI. Okay. So I have named the medians. And point of concurrence of median is called as centroid. So like that we have done the third sum. Third sum is complete. Rub off these arcs. I hope you all understood. Now in the next sum, that is sum number 5, they are asking us to draw a right angle triangle XYZ, draw its median and show point of concurrence by G. Let us draw a right angle triangle. For that I will draw the base, or perfectly we will draw. So we have a base here. Any measurement you can take. Keep the keep the protractor on one point. That is this point, vertex. Keep the protractor nicely. Okay. Now mark 90 degree. 90 degree is here. We don't want such a long side. Just to keep the scale so that you have the 90 degree perfectly. Here is the 90 degree. This is a 90 degree. And this was the vertex. So, okay. This much is enough. And join the other two endpoints. And we have a right angled triangle. Name it as X, Y, Z. We will draw the median. Now I told you, either you can draw by a compass, or here just they are asking us to draw the median. They did not ask construct it using compass. Nothing is specified. So anyway you can draw. Only thing you should know, what is the median. What is the median? The segment from the vertex to the midpoint of the opposite side. So let us find out the midpoint of every side and keep. So I have this, I am using set square as my scale. You can measure the length. Now your triangle's length will differ. Find out the midpoint. That is, here the midpoint is coming, segment is, the length is coming to be 4.2. So 4.2's half will be 2.1, no? So the midpoint will be somewhat here, 2.1. Okay, this is an easy method, direct method. The previous one was 100% accurate method. So 4.2's midpoint is 2.1. So I have marked the midpoint. This is the midpoint. Similarly, I will measure this side. This side is coming to be 4, not exactly 4. 3.8 I can take. 3.8. 3.8's half will be, okay, 3.8's half is 1.9. So 1.9 means it will be here. So I got the next midpoint. Now midpoint of the hypotenuse. Measure the side of the hypotenuse. Measure the length of the hypotenuse. The hypotenuse is 5.6. 5.6, no? 5.6 half will be 5.6 upon 2. 2 2s are 2 8s are 2.8. So 2.5, 2.6, 2.7, 2.8. Here. 2.8. So this also I got the midpoint. Now let us get the median from X, midpoint of the opposite side. That is X to this point. Now from the next vertex Y to midpoint of the opposite side, that is this point, Y to this point. Now the third vertex is Z. Z to midpoint is here. Okay. So all the medians are passing through a single point. That means the measurements that we did, there is no mistake in that. Point of concurrence will be G, centroid, and we will name the median. As you want, you can name X, A, Y, B, Z, C. These are the medians. Understood? So this is a simple way to get the medians. Now the sixth sum we have, draw isosceles triangle, name is not given, and draw the median and altitude. Both we have to show. Now what is an isosceles triangle? A triangle in which two sides are congruent. A triangle in which any two sides are of equal length or congruent is called as an isosceles triangle. So let us first draw an isosceles triangle. Let's draw an isosceles triangle. I took the base as 5 centimeter. Other two sides, I'll take the other two sides as 6 centimeter. 6 centimeter I have taken. Keep the compass here. Draw arc. Keep the compass at this point. Cut that arc. You get the point of intersection. Join to the end point neatly. All the construction you have to do with pencil so that the figure comes clearly. I am using a pen. Name of the triangle is not mentioned in the question. We will name it as any name you can give. I'll name it as PQR. PQR. It is isosceles triangle. So these two sides congruent I showed. Now let us first draw the median, which is very easy to get. No, median means you have to just find the midpoint. Now this is already 5 centimeter. So the midpoint will be 2.5. 2.5 is here. I marked the midpoint. Okay. I'll draw the first median. Yes. Okay. Now for PQ, how much we had taken PQ length as 6 centimeter. No, 6 centimeters midpoint will be 3 centimeter. Mark the midpoint here. Similarly, I'll mark the midpoint for the other side. This is also 6 centimeter here. Now draw the median vertex to the midpoint of the opposite side. So vertex is R. Carefully join. Very easy. This is very easy. Median is very easy. If asked, you can use a compass. Otherwise, you can do by this method. Similarly, midpoint of the third side and the opposite vertex is Q. So join Q and the opposite vertex. Done? So you can, all the medians are passing through a single point. That point of concurrence will be G, no? Now they are asking us to draw the altitude also. Hope you remember how we did the altitude. How you did the altitude? This base for QR, if you are drawing the altitude, the base of the set square you will keep here. And this part should pass through the opposite vertex. For QR, the opposite vertex is P. So slowly slide. I went up. Okay, you can see that. What did you see? The altitude as well as the median of an isosceles triangle for side QR is the same. For side QR, altitude is also, let us name it as PA. Altitude is also segment PA, median is also segment P. So that work is done. Now for side PR, let us see. Keep the base on PR. PR's opposite vertex is Q. So slightly come to Q. Yes. This way, no? Coming correctly? So now you draw the altitude for side PR. Slowly show it. Okay. This is the altitude, 90 degree. Similarly, for this side over, for this side we got already, this is altitude as well as median. Now the third side is PQ. Okay. So keep the base on PQ and the opposite vertex is R. Slowly glide till it touch R. Yes, R is here. So slightly do the adjustment. Okay. Now draw the altitude. Yes. So we have the altitude. That is here. This is the point of concurrence of altitude. And this is the point of concurrence of median. Okay, you get it properly. Here because I did with pencil, there is a slight difference. No, it should come at a single point. This was the point of concurrence of median. So this we will name it as G, and this is the point of concurrence of altitude. So here I'll name it as O. Understood? Even if you are not slightly getting it that way, you can give the name O and hide that mistake. Okay? All these are the tricks that you have to learn. In a hurry, if you don't get time, don't go for redrawing it. Understood? Okay. So now this way, as you can see, O is the orthocenter and G is the centroid. You have to show it in your figure. Now, Now, to explain one property of centroid, I am taking the figure which we drew before, that is XYZ. Triangle XYZ, the first figure that we drew, no? Sum number 5, that figure I am taking to explain something. Okay, listen carefully. Now, for a centroid, there is a property that if you measure the length, suppose from any vertex, which are the three vertex X, Y and Z. Children, always remember that you have to start from the vertex. That is the clue. Always start from vertex X or vertex Y or vertex Z. That is the rule. So if I measure, suppose I start with vertex Y. If I measure YG and GB, YG is to GB, YG upon GB. Okay. If I find out the length of these two, I will always get the ratio as 2:1, 2 upon 1. Okay, 2:1. We can check for one. We can check for one example here. As I can see, YG is, this is 1.5, 1.6, 1.7, 1.8. So YG is 1.8 and GB length I'll measure. GB is 1. Okay. GB is 1. So slightly is it coming to be same? 2:1.8 means it's nothing but 2 only. No, close to 2. So 2:1. It is always found that YG upon GB is equal to 2:1. The ratio you will get it as 2:1. Similarly, any measurement, any length, the next vertex if I take X. So you will start with XG is to GA. XG upon GA will also be 2:1. Let us take XG. Where is XG? Measure XG. Using scale you measure it properly. XG I am getting it as XG I am getting it as 2.9 and GA I am getting it as 1.5. Can you see roughly 2.9 is nothing but 3, no? And 1.5. That means 2:1 double. 1.5's double is 3. 1.5 plus 1.5 is 3, no? So 2:1. So what will be the third relation now? XG upon GA over YG upon GB over. Now the third vertex is Z. So start from Z. ZG upon GC will be 2:1. Always remember. From the vertex to the centroid. From the centroid to the midpoint will be 2:1. So this part will always be bigger than the remaining part. From the vertex, this part will be bigger than the remaining part. 2 times, no? This will be half. This part will be half of the previous part. Similarly, the vertex is Y. So YG is to GB is 2:1. So if this is 1, this will be 2. If this is 2, this will be 4. Like that. Understood? Okay. So now depending upon this, we will take the last sum. So from the previous property, let us apply in this sum. Let us apply that in this sum. RG is given as 2.5. Then what will be GC? So what is the relation I told you? From the vertex you have to start. That is CG upon GR will be 2:1, no? 2 upon 1. From the vertex you have to start always. CG upon GR is 2:1. So, CG we don't know. GR is given as 2.5. So, this is the relation 2 upon 1. So, how much will be CG? Therefore, CG is equal to CG into 1 is CG. 2.5 into 2 is 5. So, CG will be 5. Without this also you can write directly. Because we know that from the vertex, this part will be 2 times the later part. So, if this part, if RG is 2.5, then the longer part will be double. 2.5 is double is 5. Or you can use the relation. So, how much is this? 5. Now, the second sum. The second sum is, they are asking, if length of BG is 6, then find the length of BQ. Okay. Where is BG? BG is here. From the vertex. This is the bigger side. BG is given as 6. So, how much will be GQ? Half of this, no? Half of 6 is 3. GQ will be 3. Now, they are asking how much is BQ? Where is BQ? BQ is this whole thing. How much will be BQ? 6 plus 3 will be 9. So, write length of BQ is equal to 9. Understood? Or if you want me to explain, BG upon GQ is equal to 2 upon 1. BG upon GQ is equal to 2 upon 1. BG is given as 6. So, GQ you will get 2 upon 1. Therefore, cross multiply. 6 into 1, 6 is equal to 2 into GQ. 2 into GQ. Now, 2 will come to this side. So, 6 upon 2 is GQ. So, how much is GQ? GQ we got as 3. Correct, no? So, how much will be this BQ? 6 plus 3, 9. You can write it directly also. Because they are just asking it in the form of blanks. Now, the third question. I will do it here. The third question they are asking. If length of AP is 6, then find AG and GP. A and GP. Both are asked. Let's see the figure. AP. AP is given as 6. The whole thing is 6. So, how will you divide it in the ratio 2:1? Apply your mathematical skills. If whole AP is 6, and we know that, what is the ratio? From the vertex, AG upon GP should be 2:1. So, how will you divide that 6 in the ratio 2:1? How much will be AG? If you add both, you should get 6. How will you divide? How will you divide that? This you will give it as 4 and this you will give it as 2, no? This part you will give it as 4 and the remaining part you will give it as 2. The remaining part will always be half of the first part, no? And 4 plus 2 is 6. That is AP is 6. So, can you get how much is AG? AG will be 4 and GP will be 2. Is it fine? Okay, so use your mathematical skills here and find the answer. Always see to it that you write the ratio from the vertex. AG upon GP, CG upon GR and BG upon GQ. Understood? So, we have completed the chapter altitude and median of triangle. I hope you have gone through. You understood all the sums. In the next class, we will meet with a new chapter. Till then, bye students.